Okay. So the main stuff that we're going to be learning about today is factored form and then how we can, so factored form, by the way, takes standard form and it factors it. So if you factor standard form, you end up with a form of a function that is written as y equals a times x minus p times x minus q. Where x and y, by the way, x and y show up in every form of an equation. We got y equals ax squared plus bx plus c. That's standard form. X and y are there. We have our factored form here. And even in vertex form, we have x and y. So if you write vertex form off to the side here, just to remind ourselves what that looks like, that was y equals x minus h and then squared plus k. So this was vertex form right here. So these are the three forms of functions we have, three forms of quadratic functions. Each of them includes x and y. What's the other common variable among all three terms? A, yeah. So A is the same across all three of them. A determines the width, whether it's narrow or wide. A determines all right. A also determines whether or not the quadratic parabola faces up or down. So that can be found on any three of those types of equations. Vertex form gives you the vertex with h and k. And then these values here, p and q, are the zeros of the function, meaning where the line crosses the x-axis. So the zeros, the x-intercepts, that's another thing that they're called, x-intercepts. The x-intercepts of the graph correspond to the zeros of the function. Two zeros denote three intervals of x values. What do you think that means? Two zeros denote three intervals of x values. We'll talk about it right here. Here's a zero. Here's a zero. Intervals are basically what's happening to the left of the first zero, what's happening in between the two zeros, and what's happening to the right of the other zero. So you have one interval here that goes up forever there. You have another interval that's in between where it comes down and then goes back up. And then you have a third interval after this zero where it's going up forever. So that's what that means when you got three intervals. So for this particular function here, if you want to figure out where the zeros of the function are, you set the equation equal to 0 because we're talking about when y is equal to 0. So if you replace y with 0, whatever x is where it crosses the x-axis because y is equal to 0. So if you factor this like we've been practicing, this factors to 2x plus 7 times x minus 2. And then if you solve each set of parentheses by setting them equal to 0, you end up with an x-intercept at -7/2 and another x-intercept at 2. So those would be the zeros of the function. And then we're talking about intervals. We'll talk about this a little bit later where we get to positive intervals where it's positive, intervals where it's negative. We'll talk about that as well. So this is what we will be learning about today. So it's just like a front loading of like, hey, this is what we're going to be doing. So let's turn the page, start practicing a little bit. First thing we're going to do is once again, do a little bit of review of factoring. We've seen this particular one, that exact problem, probably 5 or 6 times already. So this is what's known as a difference of squares. If you have a perfect square first term and a perfect square second term, and there's subtraction in between the two, then this will factor to the square root of each factor with one set of parentheses having a plus and the other having a minus. And it doesn't matter which one gets the plus or the minus as long as you have one of each. So we got x plus 3 times x minus 3 for that. This next one here, let's go and use our slip and slide method. By the way, just a reminder, you should always look for a GCF, even though there aren't any on these two. You should always look for a GCF first. So we're going to multiply 3 times 2. 3 times 2 is 6. So that's going to be x squared minus 7x plus 6. Now we're looking for two factors of 6 that also add to -7. If you multiply to a positive and add to a negative, what types of factors do you have to have? Both negative. Good. So two negative numbers that multiply to positive 6 and add to -7. Yeah, 1 and 6. Yep. So x minus 1 times x minus 6. All right, write that down. Jaime, put it away. Please, write this down. All right. And then the last thing we need to do. What's next? Yeah, divide by the original value of a, which is 3. So if we divide 1 by 3 and we divide 6 by 3, 6 will divide by 3. 1 does not divide evenly. So we're going to take our value of 3, and we are going to slide it in front of x. So this first set of parentheses will be 3x minus 1, and the second one is going to be x minus 2, and that's our factored form for that. So that's what we just did like the first 3 days of this week. So we're going to keep doing this. By the way, factoring will not go away. It's not going to go away in this unit. It'll come back in subsequent units later on in Algebra 2B. So your ability to factor is going to play a role in like some of the success that you have in this class. So if you're struggling with factoring and you want some more help with it, or you need some more like examples to work with, let me know. All right. Questions on example 1 here? Good to go then, hopefully. All right, example 2. Relate the factors to zeros of a function. All right, so this isn't really going to be much different than what we just did. So the graph shows the function y equals x squared minus 9x plus 20. Identify the zeros of the function by factoring. How do the zeros relate to the factors? Well, the zeros, by the way, are always going to be the values of x that make the set of parentheses equal to 0. That's what ends up happening. So this one here, all we're doing is looking for two numbers that multiply to 20 and add to -9. So once again, multiplying to a negative or a positive, adding to a negative means two negative factors. So what two negative numbers will multiply to positive 20 and add to -9? 4 and 5. All right, x minus 4 times x minus 5. And I'm going to write equals 0. Because anytime we're figuring out the zeros of a function, we need to set the entire quadratic function equal to 0. And then to actually solve, we're going to take each set of parentheses and set them equal to 0. When we do this, by the way, this is called the zero product property. And the zero product property is one of the most basic things in math, and that is if you multiply two things together and the answer is 0, what do you know about at least one of the two numbers? If you multiply two things together and the result is 0, what has to be true about at least one of the numbers? At least one of them has to be 0, right? Maybe both. So like this set of parentheses turns into a number. This set of parentheses turns into a number. If you multiply that set by that set and the result is 0, that means that either this set or that set or both are equal to 0. So that's what we're going to do. We're going to say x minus 4 equals 0. And we're going to have x minus 5 equals 0. And then we'll very quickly solve for x. So for the first one here, we're going to add 4 to both sides, x equals 4. And on the second one, we're going to add 5 to both sides, x equals 5. And you can see on our graph over here, I'll do a red dot for the x equals 4. And I'll do a blue dot for the x equals 5. Those are the zeros of the function. So anytime you want to figure out where the graph crosses the x-axis, that's how you can do it. So try A and B on your own. So this is the same thing we just did, by the way. In order to get this to work, you have to set the function equal to 0. So let's go ahead and actually, we'll get it set equal to 0, and then we'll solve. So for the first one, how do we get this thing equal to 0? Before we factor, we got to get it equal to 0. Subtract 20 from both sides. Good. So that's going to be x squared plus 8x minus 20 equals 0. And in general, having an a value that is non-negative is always a good idea. So to set this one equal to 0, I would not subtract 2x squared from both sides. I would subtract the 3x and the 2. And so that'll give us 2x squared minus 3x minus 2 equals 0. All right. So from there, I want you to factor and solve. I'll give you 2 minutes on that. All right, so for A, what's our factored form? X minus 2 and x plus 10, all right? So 10 times negative 2 is negative 20, 10 plus negative 2 is positive 8. So what are the answers? Negative 10 and 2, good. So x equals 10, x equals negative 10, x equals 2. Great. That's it for A. Any questions on that? So factor. If you know the answers are just going to be opposites of those, you don't need to write the equations and actually solve them. You can just write the answer. That's fine. You can use mental math to solve what x is going to be here and here. Feel free to write your answers. For B, we wrote 2x squared minus 3x minus 2 equals 0. So first thing we need to do here is multiply the 2 times the negative 2 at the end to get x squared minus 3x minus 4. Then we're going to factor that and get x minus 4 times x plus 1 equals 0. Then we have to divide both of those numbers in the parentheses by 2, and that will end up factoring to x minus 2 times 2x plus 1. So you have to use the slip and slide method on that one. Anybody have the answers for this? So 2 and negative 1/2. Yeah. So x equals 2 and x equals negative 1/2. If you set 2x plus 1 equal to 0, you'd subtract 1 from each side to get 2x equals negative 1, then divide by 2 to get x equals negative 1/2. So those are our two answers for B. Questions on A or B before we move on? I'm moving pretty quick today because we're not doing a lot more than what we did the last 3 days, which is why we did the last 3 days, so we could kind of get through this one quickly. All right, we're looking for an error on this last one here. So it says, Anna solved the equation 8x, x squared minus 8x minus 20. So that's this one here. That's the one we just did. Equals 0 by factoring. She wrote x minus 10 times x plus 2 equals 0. And expected the x-intercepts of the function to be negative 10 and 2. Was she right? Was she right about the zeros? Yeah, she was right about the zeros. What was she wrong about? Yeah, she did not factor it correctly. So sometimes this happens where you stumble upon the correct answer, even though you didn't use the process correctly. If that happens on a test, I would still give you most of the credit because you got the right answer. But if you accidentally get the right answer, I'm going to mark you down a little bit for that, just because you need to know how to do it in the correct way, because there's a chance that you're going to end up kind of doing different things on the same types of problems, which is never a good thing. You want to be doing the same things on the same types of problems. So yes, she got the answer right. No, she did not factor correctly. All right, flip it over. Just one more page. We're moving pretty quickly through this today. So this next one, here we go. This is where we can actually use what we're dealing with here. So I'm hoping that most people are familiar with what it looks like when you throw a baseball. So it says the baseball is thrown from the upper deck of a stadium. It's 128 feet above the ground. The function h of x equals negative 16x squared plus 32x plus 128 gives the height of the ball x seconds after it is thrown. So at 0 seconds before it's thrown, it has a height of 128, which is where it starts. That's great. How long will it take the ball to reach the ground? So what is the height of the ground? 0. The height of the ground is 0. So this will be a y value of 0, which means we're figuring out the zeros of the function. So we need to figure out what is the x value when y is 0. So we're going to say negative 16x squared plus 32x plus 128 equals 0. Because we're trying to figure out how long does it take x for the ball to reach the ground, which is a height of 0. First thing we should always look for is what? Before we even start factoring? A GCF. Is there a GCF here? If so, what is it? You can use your multiplication chart as well. 16, yeah. And I would actually say negative 16. Because when we're factoring, it's always good to have the value of a as a positive. So we can actually divide out negative 16 from all three of those. So that'll be negative 16, which will be x squared minus 2x minus 8. That's a lot easier to factor. Imagine having to multiply negative 16 and 128 and figuring out the factors that actually work with that. That would be really irritating. So the fact that there's a GCF makes this a lot easier. So let's see, give me two numbers that multiply to negative 8 and add to negative 2. Yeah, negative 4 and positive 2. Good. So we got negative 16, x minus 4, x plus 2 equals 0. What are our two values for x? X equals 4, x equals negative 2. Which of those values makes sense for how long it takes a ball to reach the ground? Why 4 and not negative 2? Yeah, that negative 2 indicates negative time. That doesn't make sense. So even though there are two x-intercepts here, there are two zeros, only one of them makes sense with the scenario, which is how long it's going to take. So cross off the negative 2. By the way, if I were to ask you, how long does it take for the ball to reach the ground? And you gave me an answer of x equals 4. That's a weird way to communicate, isn't it? Like, that's not how people talk. How long does it take the ball to reach the ground? X equals 4. That's not what I asked. What would you say? It took 4 seconds, yeah. So it took 4 seconds. All right, that's our answer. When you answer a word problem, please use words. And I know you've probably been told that since you were about 5 years old. Anytime you've ever done a word problem in math, your teacher probably has said from day one, write your answer in a complete sentence using words, which is true because that's how people talk. So write your answer as if you were communicating it to someone else with words. All right. Here's an interesting question. Any questions on that one, by the way? Does it make sense that we have to use the positive one and not the negative one? Negative time doesn't make sense. Positive time does make sense. Okay. All right. Next one. Determine the positive or negative intervals. Now, on a problem like this, it's a good idea to just kind of imagine like a sketch of the graph. So let's think about this for a second. We've got ourselves, I'm just going to set up an XY axis over here. What's our value of A? 1. Does this graph face up or down? Up. Okay. Our y-intercept is at negative 21. And then our vertex is going to be at, what is that? 2 something else, right? Opposite of B is 4 over 2 times A, which would be 2. 4 divided by 2 is 2. So our y-intercept is at negative 21, and our vertex is going to be somewhere at like positive 2. I'm not putting numbers on here, by the way, because it doesn't really matter. What I want to do is just get a rough visual of what's going on here. So the sketch of this graph, let's go ahead and finish. Let's factor this real quick, and then we'll get a little more information. Then we can do a quick sketch of the graph and determine the intervals. So giving yourself a very rough visual can really help you answer these types of questions. So let's factor that. So we're going to have x squared minus 4x minus 21 equals 0. Two numbers that multiply to negative 21 and add to negative 4. Negative 7 and 3. So x minus 7 times x plus 3 equals 0. So then our x-intercepts are going to be at 7 and at negative 3. Positive 7 and negative 3. Great. So negative 3, I don't know, maybe that's here. Positive 7, I don't know, maybe that's over there. But what we do need is, I mean, that's going to be, I don't know, maybe the vertex is somewhere down there. We don't even need to know what the y value of the vertex is. We just need a general sketch here. Because what it's asking us is, on which intervals is it negative? Where are the y values negative? Are the y values negative? No, this is positive y values. Is it negative yet? Is it negative yet? Is it negative yet? Yeah. Is it still negative? Yeah. Is it still negative? Still negative? Yeah. Still negative? No. So on what intervals between what two numbers on the graph, x value wise, are the y values negative? Between -3 and +7. Yeah. Our x-intercept here of -3, our x-intercept here +7, the graph is negative between those points, and we have a visual to determine that. Because if a was negative, it would be flipped upside down, and it would be opposite. It would be negative over here and negative over here, not negative in between. So we're going to say the interval here, by the way, so this is going to be between here and here. All of the x values between those 2 points on the x-axis are where the y values of the graph are negative. So that means that we're going to get a compound inequality where x, all the values of x, are between -3 and 7, including those two values. And usually when I do something like this, I'll put the x first, and I'll put the smaller number here, and I'll put the larger number here, and then less than or equal, less than or equal. Now, if it was the other way around, if I were to ask you real quick, on which intervals is the function positive? So let's do this over here. Intervals where, glad I don't teach English, where y is positive. Intervals where y is positive. Where are they positive? Where are the y values positive? So that would be like less than -3, right? Because that would be on the x-axis less than -3. And over here, that would be more than or equal to 7, right? Actually, yeah, more than or equal to 7. Or I guess greater than. Oh, you know what? I made a mistake on the inequalities here. It shouldn't be or equal to. It should just be less than. Because if it's equal to those, then it's 0. We want negative. We shouldn't have those lines underneath it. That's on me. I'm sorry. All right, so this last one here, the y values are positive when x is less than -3, or when x is greater than 7. This is not going to be a similar looking compound inequality because when you have your variable in the middle, that means that the numbers can exist at the same time. Every number that is greater than -3 and less than 7 has overlap, right? 0 is both greater than -3 and also less than 7 at the same time. If you have -4, -4 is only less than -3. It's not greater than 7. So when it's outside like that, you have to write them separately. If it's in between, then you can write them together. Does that kind of make sense with the way we do the inequalities? Okay. Let's see. Is it always true that the y values of a quadratic function have opposite signs on either side of the 0 of a function? The y values of a quadratic function have opposite signs on either side of a 0 of the function. I would say yes to that. That would be my thought. We don't need to write it down, but it'd be nice to just talk about it real quick. I would say, yeah, that's probably true. Look in here. Example was that? That was example 5. Oh, wait, hold up. I see. Okay. I misunderstood the question. So it's asking, is it always true that the y values of quadratic function have opposite signs on either side of it? So basically it's saying, will a quadratic function, this is a better way of maybe asking this, will a quadratic function always come into contact or cross over the x-axis? No. Okay. That's probably a better way of asking that. This is kind of a convoluted way. Because a quadratic, a parabola could be entirely above the x-axis or upside down and entirely below it. So it doesn't have to have opposite values of y. It only has opposite values of y or positive and negative values of y if it crosses over. So, which it won't always do that. Okay. Number 6. Here's an interesting question. This one is going to require a formula that we don't have yet. So I'm going to have you write down a formula in just a second. So pay close attention here, please. This one says, write an equation of a parabola with x-intercepts at 3, 0 and negative 3, 0 and passes through the point 1, 2. So what is our, we saw it earlier in the concept summary. Somebody go back and read it to me. What is the basic form of a factored form of a quadratic? Is y equals, okay. It is from the back of the front page, near the top. Factored form of a quadratic. Wait, this one ours didn't have a squared though. It was x minus p and then x minus q, right? Yeah. That one right there. Where p and q were what? What did it say on that after it said the function? It said p and q were equal to the zeros of the function. Okay, you ready? So take a look. If y equals 0, that's one of our zeros. If y equals 0, that's another one of our zeros. It does not matter which one is p or which one is q. I'm just going to go in alphabetical order. So the first one I see, 3, that's going to be p. Negative 3, that'll be q. Some random point, what should we label this one? Coordinates always have x and y. Good. Which means we're going to end up solving for what? Kind of like we did with vertex one. What variable do we not have? Hey, yeah. All right. So here we go. We're going to say 2 equals a times 1 minus 3 times, I'm going to write 1 plus 3. I'd rather write 1 plus 3 than 1 minus negative 3. So we're just plugging in for p, q, x, and y, and then we're going to solve for a. 1 minus 3, what does that equal? Negative 2, okay. 1 plus 3, 4. 4 times negative 2, negative 8. All right, so 2 is equal to negative 8a. How do we get a by itself? Divide by negative 8, okay. What is 2 divided by negative 8? Tell me in a fraction. Negative 1/4. Good. So a equals negative 1/4. So we're going to get y equals negative 1/4 x minus 3 times x plus 3. That's our function right there. Take our value of a, plug it back into the regular format, keeping p and q, but turning x and y back into just regular x and y. Kind of like with what we did with vertex form, kind of like with what we did with standard form, we're doing now the same thing with factored form. Let's see. Last question, and then you get started on your assignment here. Is there any other parabola with x-intercepts at negative 2, 0, and negative 1, 0? Give an equation or explain why there's no such parabola. I'm not sure which one it's referring to be honest. Oh, okay, sorry, it's referring to one from your textbook that you did not see yet. So I'm gonna write the original equation, and then I'm gonna have you just give me an answer to that real quick. So the first thing we're gonna look at is, so the function is y equals 10 times x plus 2 times x plus 1. I'm hoping that this will be a pretty quick question to answer. Is there any other parabola with x-intercepts at -2 and -1 aside from this one? There's only one parabola that could ever cross through -2 and -1 on the x-axis? No. Let's, it says, give an equation or explain why. I'm just gonna give an equation. So is there any other? Yes. Yes, there is. Here's an example. Y equals x plus 2 times x plus 1. Just get rid of the 10. The 10 doesn't need to be there. The 10 is going to have the same x-intercepts. It's just going to be a lot narrower. So not only is there like more than one, there's an infinite amount of possible different parabolas that could have x-intercepts of -2 and -1. This is just one other example. All right. For your assignment, that's it for notes, by the way. Go ahead and stop.